Beach Boys. We got a good one today. How you doing?
Good. We fulfilled our mission of getting a Q&A with the SV development team,
Yep.
and it turned out, I think, pretty great.
Yeah.
We got every question pretty much answered from the Reddit thread. Um, we're going to make this introduction short so everyone can kind of just get into it.
Yeah.
But we wanted to give another plug to keyport.tv, which is pretty much going to be the future of where we put all of our videos. Um, it's using the cache port technology developed by Handcache. Eventually, we will be entirely putting content out on there and kind of removing our general YouTube channel, but maybe uploading things weeks later to YouTube. But we're really excited about this. We are going to put this Q&A up on Keyport for about 24 hours, just if you want to preview it there, if that's how you're watching it. But we'll put a link to how to use it, how to set it up, all that kind of stuff. Once Handcache and CachePort are on iOS, we'll kind of make that full transition. But we don't want to exclude
Yeah.
anybody that's on Apple like Corey. So
Yeah. Yeah. We want to make sure that people can still listen to our stuff, including myself.
Cool. Yeah, I don't think we need to make this too long, but we talked with Steve Shatters, Daniel Connolly from the SV client, and got answers to just about everything I think you could ask for. So
Yeah. Yeah. I think for this might be the first time that people have seen both of them together, like on camera talking. A lot of people have read things online about them, and um, yeah, we're very excited. We were pretty excited to get this Q&A lined up with them. And I don't think it was a softball interview, like some people were concerned, but
let us know.
oh well.
Yeah.
Softball's hard sometimes. So,
All right. Cool. Well, let
all
us
right.
know what you think in keyport.tv. We'll be pushing that
Yeah.
hard, but
Yeah.
great.
All right. Enjoy.
All right. So thank you, Daniel and Steve, for joining us. We're joined by Steve Shatters, Daniel Connolly from Nchain, also the lead developers on the Satoshi's Vision client. So Daniel and Steve, if you guys just want to introduce yourselves before we kind of get started here. Who are you guys and how'd you get started?
Sure. I'm Steve Shatters. In Chain, I'm the Director of Solutions and Engineering, and specifically for Bitcoin SV, I'm the Technical Director of the project, which means that I'm a bit less hands-on than Daniel, but I handle a lot of the liaison with the miners that commission the project.
Hi, I'm Daniel. The lead developer for Bitcoin SV. As the team's grown, that means that I do less actual coding myself, but more organizing the team and organizing what we're working on.
Great. So we took some questions. We asked them on Reddit to have people come in, post their questions. We tried to take as many of those as we could and eliminate some of the duplicates. So we're going to kind of go through each question one by one. We added some questions of our own in, and we'll try and get through most of these if we can. So I think we just wanted to start out and ask, Bitcoin Cash is a little bit over a year old now. Bitcoin itself is 10 years old, but in the past, a little over a year now, what has the process been like for you guys working with the multiple development teams, and why is it important that the Satoshi's Vision client exists today?
Yes, we've been in touch with the developer teams for quite some time. I think a bi-weekly meeting of Bitcoin Cash developers across all implementations started around November last year. I myself joined those in January or February of this year, and Daniel a few months later. We communicate with all of those teams, and I think it's not been without its challenges. It's well known that there's a lot of disagreement around it, but what I do look forward to in the near future is a day when the consensus issues themselves are all rather settled, and if we get to that point, then there's not going to be much reason for the different developer teams to disagree on stuff. They might disagree on non-consensus related stuff, but that's not the end of the world, because you know, Bitcoin Unlimited is free to go and implement whatever they want in the back end of Bitcoin Unlimited, and SV is free to do whatever they want in the back end. And if they interoperate on a non-consensus level, great. If they don't, not such a big problem. There'll always be bridges between the two. So yeah, I think going forward, the complications of having so many personalities with wildly different ideas are going to get less and less.
And I guess moving forward now, another question about the test net. A lot of people on Reddit have been kind of asking what the testing process for Bitcoin SV has been like. If you guys plan on releasing any of those results from the testing.
Do you want to take that one, Daniel?
Sure, yeah. So with our release, what we concentrated on was stability, right? With the first release of Bitcoin SV. And that involved doing a large amount of additional testing, particularly not so much at the unit test level, but at the more system tests. So setting up test networks, performing tests and making sure that the software behaved as we expected, right? Confirming the changes we made and making sure there weren't any other side effects. Because of the, you know, it was quite a rush to release this, to release the first version. So we've got our test results all documented, but not in a way that we can really release them. We're thinking about that, about how to do that, but we're not there yet.
Yeah, I just want to tidy that up, because we've spent a lot of our time developing really robust test processes, and the reporting is something that we can read on our internal systems easily, but we need to tidy that up to give it out for public release. And the priority for us was making sure that the software was safe to use. We've established a test framework that involves a progression of code changes through multiple test environments. I think it's 5 different test environments before it gets the QA stamp of approval. And as to the question of the testnet, yeah, we've got 4 of them. We've got testnet 1 and testnet 2. Slightly different numbering scheme to the testnet 3 that everyone's probably used to. That's just how we reference them internally. They're both forks of testnet 3. One we used for activation testing, so we would test up before and after activation. That one's set to reset every couple of days. The other one was set to post activation, so that we could test all of the consensus changes. The third one was a performance test network, which I think most people have probably have heard us refer to before as gigablock testnet. I get my tongue tied in a knot every time I try to say that word, so I've started calling it performance test network. I think we're planning on having 2 of those. One that we can just do our own stuff with and experiment without having to worry about external unknown factors going on, other people joining it and doing stuff that we don't know about, that affects our ability to baseline the performance tests. But the other one, which I think might still be a work in progress, so Daniel might be able to answer that one, is one that we want basically everyone to be able to join, and they can try and mess stuff up as bad as they want.
Yep. So we recently shared the details of testnet 1 and 2 with the other VCH developer group. The Gigablock test network, we've shared that with one other person so far, but one other group, I should say. But we're building it as Steve pointed out, to be publicly accessible.
I think that was my next question. I saw that you posted on Twitter about the Gigablock, the revived Gigablock testnet initiative. And so it looked like blocks bigger than 32 megabytes were being mined and propagated there, but maybe the block explorers themselves were going down. What does that revived test initiative look like, and have the results?
Well, that's what the Gigablock test network is. So it's the Gigablock test network was first set up by Bitcoin Unlimited with Enchain's help, and they did some great work on that. And we wanted to revive it, so we wanted to bring it back and do some large-scale testing on it. It's a flexible network. At one point, we had 8 different large nodes spread across the globe, sort of mirroring the old one. Right now, we scaled that back because we're not using it at the moment. So now there's, I think, 3. We have produced some large blocks there, and we've discovered it's helped us a lot in our research into the scaling capabilities of Bitcoin SV. So it's guided the work that the team's been doing for the last month or 2 on the improvements that we need for scalability.
Great.
I think that's actually a good point to kind of frame where our priorities have been in kind of 2 separate stages. I think, as Daniel mentioned before, because of the time constraints, we kept the chain set for the October 15 release as minimal as possible. It was just the consensus changes. We didn't do any work on performance at all. And we put all of our focus and energy into establishing the QA process and making sure that that change was safe. And that was a good process for us to go through. It highlighted what we were missing in our team. Got our recruiters very busy recruiting a test manager and more QA people. And the second stage after that is performance-related work, which, as Daniel mentioned, the results of our performance testing fed into what tasks we were going to start working on for the performance-related stuff. Now that work is still in progress. Some of the items that we identified, the code is done and it's going through the QA process, but it's not quite there yet. But that's basically the 2-stage process that we've been through so far. We have a roadmap that goes further into the future that outlines more stuff, but primarily it's been QA first, performance seconds. So the performance enhancements are close and on the horizon, but some of that work will be ongoing for quite some time.
Sure.
Some of the changes we need for the performance are really quite large, yeah, and really get down into the base level of the software. There's kind of 2 groups of them mainly. There's ones that are internal to the software, to Bitcoin SV itself, improving the way it works inside, and then there's other ones that do interface with the outside world. And one of those in particular, we're working closely with another group to make a compatible change. It's not consensus change or anything like that, but having the same interface on multiple different implementations will be very helpful, right? So we're working closely with them to make an improvement for scalability.
And maybe that's a good kind of, obviously Bitcoin SV, one of the main things that you guys wanted to do that some of the other developer groups weren't willing to do right now is to increase the default minimum block size or maximum block size to 128 megabytes. I kind of wanted to pick your brains a little bit about A lot of the objection to either removing the block size entirely or increasing it on a larger scale is this idea of like the infinite block attack, right? And that kind of came through in a lot of the questions. What are your thoughts on the quote unquote infinite block attack? And is it something that really exists? Is it something that miners themselves should be more proactive on preventing? Or I guess, what are your thoughts on that attack that everyone says will happen if you uncap the block size?
As I'm often quoted on Twitter and Reddit. I've said before, the infinite block attack is bullshit. Now that's a statement that I suppose is easy to take out of context, but I think the 128 meg limit is something that there's probably two schools of thought about. There are some people who think that you shouldn't increase the limit to 128 meg until the software can handle it. There are others who think that it's fine to do it now, so that the limit is increased when the software can handle it. So you don't run into the limit when the software improves and can handle it. Obviously, we're from the latter school of thought. As I said before, we've got a bunch of performance increases, performance enhancements in the pipeline. If we wait till May to increase the block size limit to 128 meg, then those performance enhancements will go in, but we won't be able to actually test it and demonstrate it on mainnet. As for the infinite block attack itself, I mean, there are a number of mitigations that you can put in place. I mean, firstly, drilling down to a bit of the tech detail. When you send a block message or send any peer-to-peer message, there's a header which has the size of the message. If someone starts sending you a message that's greater than, if someone says they're sending you a 32 meg message and you're receiving it and it gets to 33, obviously you know something's wrong, so you can drop the connection. If someone sends you a message that's 129 meg and you know that your block size limit is 128, and you know that it's pointless to kind of download that message. So, I mean, they're just some of the mitigations that you can put in place. When I say the attack is bullshit, I mean it's bullshit from the sense that it's really quite trivial to prevent it from happening. I think there is a bit of a school of thought in the Bitcoin world that if it's not in the software right now, then it kind of doesn't exist. And I disagree with that, because there are small changes that can be made to work around problems like this. One other aspect to the infinite block attack, and let's not call it the infinite block attack, let's just call it the large block attack. It takes a long time to validate. That can be gotten around by having parallel pipelines for blocks to come in. So you've got a block that's come in and it's got a node stuck on it for 2 hours or whatever, downloading it and validating it, and at some point another block is going to get mined by someone else. And as long as those two blocks aren't sort of stuck in a serial pipeline, then the problem kind of goes away.
Are there any concerns with the propagation of those larger blocks? Because there's a lot of questions around, what the practical size of scaling right now Bitcoin SV could do, and the concerns around propagating those blocks across the whole network.
Yes, I mean, there have been concerns raised about it. I think what people forget is that compact blocks next thing exist. So a 32 meg block is not sending 32 meg of data in most cases, almost all cases. The concern here that I think I do find legitimate is the Great Firewall of China. Very early on in Bitcoin SV, we started talking with miners on the other side of the firewall, and that was one of their primary concerns. We had anecdotal reports of people who were having trouble getting a stable connection any faster than 200 kilobits per second. And even with compact blocks, you've still got to get the transactions across the firewall. So we've done a lot of research into that. We've tested our own links across the firewall, rather CoinGeek's links across the firewall, that kept giving us access to some of their servers so that we could play around. And we were able to get sustained rates of 50 to 90 megabits per second, which pushes that problem quite a long way down the road into the future. I don't know the maths off the top of my head, but the size of the blocks that could sustain is pretty large. So we're looking at a couple of options. It may well be the chattiness of the peer-to-peer protocol that causes some of these issues with the Great Firewall. So we have someone building a proof of concept where tool where you basically just have one kind of TX vacuum on either side of the firewall that collects them all up and sends them off every 1 or 2 seconds as a single big chunk to eliminate some of that chattiness. The other is we're looking at building a multiplexer that will sit and suck stuff off the peer-to-peer network on one side and send it over, split it and send it over multiple links and reassemble it on the other side. So we can sort of transition the Great Firewall without too much trouble. But I mean, getting back to the core of your question, yes, there is a theoretical limit to block size propagation, and that's kind of where, propagation time, and that's kind of where Moore's law comes in. Put in faster links, and you kick that can further down the road, and you just keep on putting in faster links. I don't think 128 meg blocks are going to be an issue though with the speed of the internet that we have nowadays.
Great. The other change, I guess one of the other changes that you guys are introducing is increasing the max script size. So I think right now it's going from 201 to 500. Is that right?
Yeah.
And then, so I guess one of the questions, or I guess a few of the questions we got, was, I guess, number one, like, why not uncap it entirely? I think you guys said you ran into some concerns while testing that. And then also specifically we had a question about how certain are you that there are no remaining n-squared bugs or vulnerabilities left in script execution?
It's interesting, the decision, we were initially planning on removing that cap altogether, and the next cap that comes into play after that, the next effective cap, is a 10,000 byte limit on the size of the script. We took a more conservative route and decided to wind that back to 500. It's interesting that we copped some criticism for that. When the primary criticism, I think, that was leveled against us was that it was dangerous to increase that limit to unlimited. We did that because we were being conservative. We did some research into these log n squared bugs, attacks that people have referred to. We identified a few of them, and we had a hard think about it and thought, look, if we can find this many in a short time, we can fix them all with a whack-a-mole approach. But it does suggest that there may well be more unknown ones. So we thought about putting, taking the whack-a-mole approach, but that doesn't really give us any certainty. We will fix all of those individually, but a more global approach is to make sure that if anyone does discover one of these scripts, it doesn't bring the node to a screaming halt. So the problem here is, because the Bitcoin node is essentially single-threaded, if you get one of these scripts that locks up the script engine for a long time, everything that's behind it in the queue has to stop and wait. So what we want to do, and this is something we've got an engineer actively working on right now, is once that script validation code path is properly parallelized, parts of it already are, then we'll basically assign a few threads for well-known transaction templates, and a few threads for any type of script templates for any type of script. So if you get a few scripts that are nasty and lock up the thread for a while, that's not going to stop the node from working, because you've got these other kind of lanes of the highway that are exclusively reserved for well-known script templates, and they'll just keep on passing through. once you've got that in place, then I think we're in a much better position to get rid of that limit entirely. Because the worst that's going to happen is your non-standard script pipelines get clogged up, but everything else will keep ticking along. There are other mitigations for this as well. I mean, a node could always put a time limit on script execution if they wanted to, and that would be something that would be up to individual miners. Bitcoin SV's job, I think, is to provide the tools for the miners, and the miners can then choose, how to make use of them. If they want to set time limits on script execution, then that's a choice for them.
Yeah, I'd like to point out that a node here, when it receives a transaction through the peer-to-peer network, it doesn't have to accept that transaction. It can just reject it. If it looks suspicious to the node, it can just say, we're not gonna deal with that. Or if it takes more than 5 minutes to execute, or more than a minute even, it can just abort and just discard that transaction, right? The only time it can't do that is when it's in a block already. But then it could decide to reject the block as well. These are all possibilities that could be implemented in the software.
Yeah, and if it's in a block already, it means someone else was able to validate it. So
yeah.
And there's been like a lot of discussions about the 4 re-enabled opcodes coming: op mul, op invert, op l shift, and op r shift. Could you maybe explain the significance of those opcodes being re-enabled?
Well, I mean, partly one of the more significant things is, other than 2, which are minor variants of div and mul, they represent almost the complete set of original opcodes. I think that's not necessarily a technical issue, but it's an important milestone. Mul is one that I've heard some interesting comments about. People ask me why are you putting mul back in if you're planning on changing them to big number operations instead of the 32-bit limit that they're currently imposed upon. The simple answer to that question is that we currently have all of the other arithmetic operations except for op mul. We've got add, divide, multiply, subtract, modulo. It's a bit odd to have a script system that's got all the mathematical primitives except for multiplication. The other answer to that question is that they're useful. We've talked about a random signature solution that basically replicates the function of sig verify. That's just one example of a use case for this. I mean, most cryptographic primitive operations require mathematical operations, and bit shifts are useful for a whole ton of things. So it's really just about completing that work and completing the script engine, or rather not completing it, but putting it back the way that it was meant to be.
Yeah. Maybe to kind of wrap that question through a little bit, and I actually didn't check the validity of this, but someone said you suggested in the past that you might replace like opmul, for example, with a big num version in May. Number one, I guess, is that true? I didn't validate that, so I apologize in advance. But I guess the question generally is why introduce it now and then switch to a big num version in May? And maybe to kind of wrap that question into another one is, and I've seen Daniel, I think I saw you answer this on Reddit a little while ago, but the new opcodes are using logical shifts, and Satoshi's version uses arithmetic shifts. The general question that I think a lot of people keep bringing up is maybe in a rhetorical way, but they say, why not restore it back to the way Satoshi had it exactly? What are the benefits of changing it now to operate a little bit differently?
So there's 2 parts there, isn't there? There's the big number one, and the L shift being a bitwise shift instead of an arithmetic one. So when we've re-enabled these opcodes, we've looked at them very carefully, and we have adjusted them slightly, as we did in the past with op split, right? So the new L shift and R shift are bitwise operators. They can be used to implement arithmetic based shift. I think I posted a short script that did that. But the other way, can't do it the other way around, right? You couldn't use an arithmetic shift operator to implement a bitwise one. It's because of the ordering of the bytes in the arithmetic values. So the values that represent numbers, the little endian, which means they're swapped around to what many other systems use, what I'd consider normal, big endian. And if you start shifting that properly as a number, then the shifting sequence in the bytes is a bit strange. So it couldn't go the other way around. You couldn't implement bitwise shift with arithmetic. So we chose to make them bitwise operators. This what we proposed, and
no, that wasn't essentially a decision that was actually made in May, or rather, it's a consequence of decisions that were made in May. So in May, I think we reintroduced and/or XOR, and that was also when the decision to replace 3 different string operators with off split was also made. So that was not a decision that we made, unilaterally. It was a decision that was made collectively with all of the BCH developers. Well, not all of them were actually in all of the meetings, but they were all invited.
So another example of that is that we originally proposed op2div and op2mul, was it, I think? And this is a single operator that multiplies the value by 2, right? But it was pointed out that that can very easily be achieved by just doing multiply by 2 instead of having a separate operator for it. So we scrapped those. We took them back out because we wanted to keep the number of operators minimal. Yeah.
There was an appetite around for keeping keeping the operators minimal. I mean, the decision of the idea to replace op substring, op left, op right with the op cap, sorry, not with the op split operator, actually came from Gavin Anderson. He made a brief appearance in the Telegram workgroups while we were working out what to do with the May opcodes, and obviously Gavin's word kind of carries a lot of weight, and we listened to him. But because we'd chosen to implement the May opcodes, the bitwise opcodes, as bitwise, treat the data as big endian data strings. Oh, sorry, big endian's not really applicable, just plain data strings. It would have been completely inconsistent to implement L shift and R shift as integer operators, because then you would have had a set of bitwise operators that operated on 2 different kinds of data, which would have just been nonsensical and very difficult for anyone to work with. So, yeah, I mean, it's a bit like Peta script hash. It wasn't a part of the original Satoshi protocol, but once some things are done, they're done, and if you want to make forward progress, you've got to work within that framework that exists.
Sure. So when we get to the big number ones, then it gets really complicated, yeah? Big number implementations, because you can't change the behavior of the existing opcodes. And I don't mean opmul, I mean the other ones, opadd and opsub, that have been there for a while. You can't suddenly make them big number ones without seriously looking at what scripts there might be out there and the impact of that change on those existing scripts, right? And the other point is you don't know what scripts are out there. Because of P2SH, there could be scripts that you don't know the content of, and you don't know what effect changing the behavior of these operators would make to those. The big number thing is tricky. So another option might be, yeah, I don't know what the options for that are. I need some serious thought behind it.
Sure.
That's something that we've reached out to other implementation teams about. I actually really would like their input on the best ways to go about restoring big number operations. It has to be done extremely carefully, and I don't know if we'll get there by May next year or when. But we're certainly willing to put a lot of resources into it, and we're more than happy to work with BU or XT or whoever wants to work with us on getting that done and getting it done safely.
I've kind of along the similar vein, Bitcoin Core introduced this concept of standard scripts, right? Standard and non-standard scripts. I've had pretty interesting conversation with like Clemens Lay about kind of use cases for non-standard scripts, as they're called. Bitcoin, I know at least one developer on Bitcoin ABC is very hesitant or kind of push back on him about doing that. And so what are your thoughts about non-standard scripts and the entire idea of like an is standard check?
I'd actually like to repurpose the concept. I think I mentioned before the multi-threaded script validation and having some dedicated for well-known script templates. When you say the word well-known script template, there's already a check in Bitcoin that kind of tells you if it's well-known or not, and is standard. I'm generally in favor of getting rid of the notion of standard transactions, but it's actually a decision for miners, and it's really more of a behavioral change than it is a technical change. There's a whole bunch of configuration options that miners can set that affect what they consider to be standard and not standard. But the reality is not too many miners are using those configuration options. So, I mean, standard transactions as a concept is meaningful to a arbitrary degree, I suppose. But yeah, I would like to make it easier for people to get non-standard scripts into Bitcoin so that they can experiment. And from discussions that I've had with CoinGeek, they're quite keen on making their miners accept, at least initially a wider variety of transactions and eventually any and all.
So I think in standard will remain important within the implementation itself for efficiency purposes, right? You want to streamline base use case cache payments through the node and prioritize them, and that's where it will remain important. But on the interfaces from the node to the rest of the network, yeah, I could easily see it being removed there.
And Connor mentioned that there's some people that disagree with Bitcoin SV and what they're doing. There's a lot of questions around why November? Why implement these changes in November? They think that maybe the 6-month delay might not cause a split. Well, first off, what do you think about the ideas of a potential split? And I guess what is the urgency for November?
Well, in November, there's going to be a divergence of consensus rules, regardless of whether we implement these new opcodes or not. Bitcoin ABC released their spec for the November hardfork change, I think on August 16th or 17th, something like that. And their client as well, and it included CTOR and it included DSV. Now, for the miners that commissioned the SV project, CTOR and DSV are controversial changes, and once they're in, they're in. They can't be reversed. I mean, CTOR, maybe you could reverse it at a later date. DSV, once someone's put a P2SH transaction into the blockchain, or even a non-P2SH transaction into the blockchain using that opcode, it's irreversible. So it's interesting that that some people refer to the Bitcoin SV project as causing a split. We're not proposing to do anything that anyone disagrees with. There might be some contention about changing the opcode limit, but what we're doing, I mean, Bitcoin ABC has already published a spec for May that is our spec for the new opcodes. So in terms of urgency, you know, should we wait? Well, the fact is that we can't. Come November, you know, it's a bit like SegWit. Once SegWit was in, yes, you arguably could get it out by spending anyone can spend transactions, but I mean, the reality is it's never going to be that easy, and it's going to cause a lot of economic disruption. So, yeah, that's it. Like, we're putting our changes in because it's not going to make a difference either way. In terms of whether there's going to be a divergence of consensus rules. There's going to be a divergence, whether whatever our changes are not controversial at all. So,
yeah, if we didn't include these changes in the November upgrade, we'd be pushing ahead with a no change scenario, right? But the November upgrade is there, so we should use it while we can. And adding these non-controversial changes to it, that's what we're doing.
Sure. Can you talk about DataSig Verify? You guys mentioned that a little bit, but what are your concerns with it? And I don't know, I guess just the general concept that's been kind of floated around because of Brian Charles is the idea that it's a subsidy, right? That it takes a whole megabyte and kind of crunches that down and makes the computation time, computation stays the same, but maybe the cost is lesser. Do you kind of share his view on that, or what are your concerns with it?
Can I say one or two things about this? There's many different ways to look at that, right? And I'm an engineer. My specialization is software. So the economics of it, I hear different opinions. I trust some more than others, but I'm not an economist, okay? I kind of agree with the ones with my limited expertise on that it's a subsidy. It looks very much like it to me, but yeah, that's not my area. What I can talk about is the software. So adding DSV adds really quite a lot of complexity to the code, right? And it's a big change to add that. And what are we going to do? Every time someone comes up with an idea, are we going to add a new opcode? How many opcodes are we going to add? I heard reports from on Twitter that Jihan was talking about hundreds of opcodes or something like that. And it's like, how big is this client going to become? How big is this node is going to have to handle every kind of weird opcode that's out there? The software is just going to get unmanageable. And DSV is that was my main consideration at the beginning was DSV, you know, if you can implement it in script, you should do, because that way that keeps the node software simple, it keeps it stable, and you know, it's easier to test at it, and it works properly and correctly. It's almost like adding that code to a microprocessor. You know, why would you do that? It's if you can implement it already in the script that is there, don't do it.
It's actually it's an interesting inconsistency, because when we were talking about adding the opcodes in May, the philosophy that seemed to drive the decisions that were able to form a consensus around that was to simplify it and keep the opcodes as minimal as possible, i.e. Where you could replicate a function by using a couple of primitive opcodes in combination, that was preferable to adding a new opcode that replaced it. Op substring is an interesting example. It's a combination of split and swap and drop opcodes to achieve it. So at a really primitive kind of script level, we've got this philosophy of let's keep it minimal, and at this sort of higher level, we've got this philosophy of, oh, let's just add a new opcode for every primitive function. and Daniel's right. It's a question of opening the floodgates. Where does it end? If we're just going to go down this road, it almost opens up the argument: why have a scripting language at all? Why not just add hard code all of these functions in one at a time? Pay to public key hash is a well-known construct. We could hard code that and not bother executing a script at all. But once we've done that, we take away all of the flexibility for people to innovate. So it's a philosophical difference, I think, but I think it's one where the position of keeping it simple kind of does make sense. All of the primitives are there to do what people need to do. The things that people don't feel like they can't do are because of the limits that exist. Yeah. If we had no opcode limit at all, if you could make a gigabyte transaction, a gigabyte script, then you could do any kind of crypto that you wanted, even with 32-bit integer operations. Once you get rid of the 32-bit limit, of course, a lot of those scripts become a lot smaller. So a Raven signature script shrinks from 100 megabytes to a couple of hundred bytes. But
I lost a good 6 months of my life diving into script. Right. Once you start getting into that language and what it can do, it's really pretty impressive how much you can achieve just using script. Now, Bitcoin was released originally with script. I mean, it didn't have to be. It could just be, instead of having a transaction with script, you could have accounts, and you could say transfer so many BTC from this public key to this one. But that's not the way it was done. It was done using script. And script provides so many capabilities if you start exploring it properly, if you start really digging into what it can do. Yeah, it's really amazing what you can do with script. I'm really looking forward to seeing some very interesting applications from that. I mean, there was I don't know how you pronounce it. Our many his zeroconf script was really interesting, right? I mean, it relies on DSV, which is a problem, but and some other things that I don't like about it, but him diving in and using script to solve this problem was really cool, and it was really good to see that.
I sent up a question to a couple of people in our research team that have been working on the Raven signature stuff this morning, actually, and I wasn't sure where they were up to with this, but they're actually working on a proof of concept, which I believe is pretty close to done, which is a Raven signature script. It will use smaller signatures so that it can fit within the current limits, but it will be, effectively the same algorithm. So I can't give you an exact date on when that will happen, but it looks like we'll have a Raven signature in the blockchain soon, a mini Raven signature.
And based on your responses, I think I kind of already know the answer to this question, but there's been a lot of questions about ending experimentation on Bitcoin. I was going to kind of turn that into the plan that Bitcoin SV is on. Do you guys see like a potential one final code, that there's going to be no new opcodes ever released, like maybe 5 years down the road, we just solidify the base protocol and move forward with that? Or are you guys more on the idea of being open-ended with appropriate testing, that we can introduce new opcodes under appropriate testing though?
I think you've got to factor in what I said before about the philosophical difference. I think new functionality can be introduced just fine. Having said that, yes, there is a place for new opcodes, but it's probably a limited place, in my opinion. The cryptographic primitive functions, for example, checksig uses ECDSA with a specific elliptic curve. Hash 256 uses SHA-256. At some point in the future, those are going to no longer be as secure as we would like them to be, and we'll replace them with different hash functions and different signature verification functions at some point. But I think that's a long way down the track.
I'd like to see more data too. Like, I'd like to see evidence that these things are needed. And the way I could imagine that happening is that, you know, that with the full scripting language, some solution is implemented, and then we discover that this is really useful, and over a period of like you know, measured in years, not days, we find a lot of transactions are using this feature. Then maybe, you know, maybe we should look at introducing an opcode to optimize it. Yeah, but optimizing before we even know if it's going to be useful, yeah, that's the wrong approach.
I think that optimization is actually going to become it's going to be an economic decision for the miners. From the miners' point of view, is it will make more sense for them to be able to optimize a particular process? Does it reduce the cost for them such that they can offer a better service to everyone else? Yeah. So ultimately, these decisions are going to be miner-made decisions, not developer decisions. Developers, of course, can offer their input. I wouldn't expect every miner to be an expert on script. But as we're already seeing, miners are actually starting to employ their own developers so that they get their own opinions. I'm not just talking about us. There are other miners in China that I know have got some really, really bright people on their staff who kind of question and challenge all of the changes, study them, and produce their own reports. And we've been lucky; we've actually been able to talk to some of those people and have some really fascinating technical discussions with them.
Sorry, so many questions I want to ask you, but maybe I will. You mentioned this a little bit further back. I wanted to get your thoughts on selfish mining, right? So you're the chief scientist of Enchain has been pretty vocal that selfish mining is not real. Steve, I know that I think at one time we're running a simulation on selfish mining. Kind of what are your thoughts on selfish mining itself? Is it an attack vector? Is it made up? Is it real?
It's a nuanced issue. So yeah, I did actually run a simulation. In fact, I started switching it off just a couple of weeks ago, and I've handed all that data over to somebody to start analysing. I'm glad I got to switch it off because it was costing me a fortune in VPSs. So it was 100 nodes on a reg test network. Well, it was slightly modified reg test, and they were all actually, you know, real nodes mining. And I haven't finished analysing the data from the full-scale test, but I did a small test late last year with just 10 miners, mainly because I just wanted to prove that it all worked before I started spending lots of money on 100 nodes. And the results I got showed that you could gain a short-term advantage with selfish mining, nowhere near what was predicted by Emmen's paper. And there could be any number of reasons for that. I did my absolute best to bias that test in favour of the selfish miner. Anywhere where it was, you know, there was a point where it could be biased. I tried to make that bias in favour of the selfish miner. So it'll need the expertise of somebody a little more statistically aware than I am to filter out all of that noise and see if we need to repeat any of those tests. But what became really apparent to me, and I spent a lot of time working on this, was because I had to factor in all of those biases. It's so easy to stop somebody from selfish mining because it's so easy to detect. You know, if you need to hold blocks back for a period of time that could range from minutes to 30 minutes, an hour, whatnot, there's obvious signs there. You're not going to have transactions that appeared on the network in the last 10 minutes or 20 minutes. If you think someone's selfish mining, you can start seeding transactions out yourself so you know exactly when they came out. the timestamp in the block is going to be off. Most miners at the moment use reasonably accurate timestamps. At the moment, well, the Bitcoin protocol is always allowed about a 2-hour window for block timestamps. So, but the timestamps that people tend to be using these days are relatively accurate. So once you're aware that selfish mining happens, it's really, really easy to start orphaning the blocks of the selfish miner. You can detect which blocks they are, and you can start manually invalidating them if you want to. I find it inconceivable that if 30% of the network is trying to attack the other 70, that the 70 aren't going to respond. They're going to respond. They're going to respond very quickly. And it takes quite some time for any advantage to be gained by the selfish miners. So they're taking a massive risk that people just aren't going to notice and aren't going to respond by trying to do anything about this. By trying to pull this off. So for me, the reality is it's probably never going to happen. And if it does, someone's going to end up with a bloody nose as a thank you for trying.
And a lot of people are comparing this upcoming November fork, I don't know if we can call it that, to the Ethereum and Ethereum Classic hard fork, and some of the confusion that can happen, especially on the exchanges, with the exchanges running different node softwares. I guess I wanted to get your thoughts on what you recommend for exchanges to do during this time where some of the clients might be incompatible, and I guess where you see November kind of ending. Where are we going to be in December, you think?
I mean, I can't predict what's going to happen after November 15. I don't think anybody can. In the past, exchanges have had during events like this. I mean, there are hard forks that are planned on certain altcoins. Zencash, for example, has them quite regularly, and exchanges routinely suspend deposits and withdrawals during these events. In some cases, they suspend trading as well. I would assume that most exchanges will probably do that until the muddy waters clear. In terms of recommendations, what I would recommend to exchanges is that they have both nodes ready. They should. I mean, most of them probably have an ABC node. Some of them already have SV nodes. I recommend that they have one of each. I also recommend they have a BU and an XT node sitting there. That's not really a hard fork related thing, but I think a November 15 related thing, I think it's just general best practice for any business that's reliant on the blockchain to have multiple implementations running so that they can switch quickly. You know, as to what the outcome will be, I mean, that's for anyone to guess, I think. But as long as exchanges are prepared and they're able to switch from one implementation to the other, then I think they'll be okay. No, that's it.
All right. I think we're getting pretty close to the end. You guys have actually done a great job answering a lot of the other questions that were scattered throughout here. I did want to ask quickly about parallelization, right? You talked about it a little bit, but have you guys done testing with not just using a single core, but parallelizing the software? And what are your thoughts on that moving forward into the future?
I'm leaving it to you, Daniel.
Right. So we've done testing in the sense of measuring the performance of the client, and research into where we can achieve the most improvements. We've also looked at other code, so I know Bitcoin Unlimited has made some improvements recently that are really impressive. And, I haven't actually tested the Bitcoin Unlimited extensively, the new one. I'd love to get around to that. But we're using a fork of the ABC code, of course. So, and there's some really big problems there with parallelization in that code. And these problems, they stem from core, which, you know, with 1 meg blocks, maybe who cares, right? But with the kind of volume that we're trying to get through, they're really important. The C++ developers, they are busy with it, but it's a lot of work to eliminate some of these problems. There's a main lock that's held by large parts of the code that is causing, you know, even though there may be multiple threads doing various bits, they're all getting stuck on this single lock, which is forcing them all to be effectively single-threaded. There are some areas where parallelization is working, but in this main flow of transactions through the system, there's a lot of work to be done there to remove this central lock, and that's what we're working on right now. We've been working on it for a while, but it was not ready for the release. It was not, you know, that kind of work needs an awful lot of testing, an awful lot of review. It was nowhere near ready for the release, and we hope to have it ready for the next release.
The next release won't be another hard fork, of course. There'll be point releases in between, yes, where we can add performance enhancements. Yeah. I think it's worth adding that, like, we're taking quite a methodical approach to this. We've got a couple of parallel streams of work going on, where we have a couple of devs mapping out the life cycle of the transaction from acceptance via the peer-to-peer interface through, you know, acceptance of the memory pool, through being mined into a block, etc., and then validated in the block. We're mapping all of that out so that we can see exactly what each kind of stage touches, so that we can then kind of break it all up. And we're doing that work as a preliminary exercise. We've got another dev in parallel working on some sort of minor code changes that will improve things in the short term. But once we have that well mapped out, and the n-chain walls, the walls of the n-chain office are going to be covered in these gigantic diagrams, because they're complicated ones. Then we'll be in a really good position to look at all of the data structures and go, okay, this one's touched by this part of the code path and that part of the code path, etc. So it's safe to separate these out and use a different lock for them. That's not safe for this part, etc. So it's the whole parallelization question is an interesting one, because it doesn't just apply to the code; it applies to our development process as well. We're working out how to parallelize development so that it doesn't get stuck behind a single developer in a pipeline. And I think in a fairly short space of time, we've gotten pretty good at that. So,
yeah, yeah, I've forgotten what I was going to say now.
No worries.
Parallelizing the workflows, yeah. Okay.
Good.
Oh, I mean, that's actually, it does lead into another point. What we don't have in the Bitcoin SV is any shortage of resources. We've got quite a lot of developers working on this project. They're extremely experienced developers, and I've been really impressed with what they've been able to pull off in a short space of time. But as and when we kind of unblock these additional parallel development paths that can be taken, yeah, we've got no shortage of people that we can add into the mix and sign them. So the pace of our progress is probably going to grow exponentially. There's always a bit of a bedding in period while we sort out our internal processes and our QA, etc., before things really start to kind of accelerate. And we're starting to see that internally in the team now. The pace of progress is really picking up.
So I remember now. So there's different types of changes here. I mean, we've got our roadmap for Bitcoin SV of where we want to go. We've got pressures to make some quick wins in regard to capacity. Yeah, and they have different. So some of the things will need a lot of work to rewrite large parts of the code, or at least to reorganize large parts of the code. And that stuff takes a long time, yeah. And then you've got the short gains things we need as well to quickly improve the capacity of the network. And getting those two needs to cooperate, to work well together without one of them, like without making a short-term win in increasing capacity that goes the wrong direction for the long-term gain that we want, right? To get all of these changes lined along the same path and making some quick improvements while at the same time having large-scale, longer-term changes that will really enhance the capacity of Bitcoin Cash. This is a challenge. This is what we're working on. Yeah, we need to keep the long term in mind, but we also need to make some short term improvements, and that's challenging.
We'll wrap it up here shortly. Thank you for your time. I would be remiss not to ask you as many interesting questions as I can. So I did want to touch on Bitcoin ABC is actually pursuing a malleability fix. What are your thoughts on transaction malleability itself, and do you think that a fix is needed?
I've not heard anyone complaining about it.
I don't see a need for it.
I mean, any malleability fix relies on changing the way that transaction IDs are calculated. And essentially that means excluding signatures from them. And I think that's a wide-reaching change. It would need to be studied very, very carefully. And it's kind of ironic because of most of the pushback that we've ever gotten for any of the changes that we wanted to implement was what's the use case? Show me the use case. And I mean, with something fundamental like a scripting language that doesn't have a multiply operation, it's almost a no-brainer. But I don't see anybody presenting a case and saying we need, I don't see any businesses coming in saying we need a malleability fix for this, and we're willing to tolerate disruption to the network and wallets having to update, etc., in order to get that. So, if a business comes and says we've got this compelling use case and it's going to transform the face of Bitcoin and it's believable, more believable, say, than the Lightning Network, then maybe it should get on the agenda and be discussed. But I'm not seeing that.
So there are a couple of small changes in the ABC plan for May that seem to be aimed at malleability. I'd encourage anyone to take a look at them. I haven't finished analyzing them myself yet, but yeah, I don't see a need for fixing malleability really.
At the very least, it's not a priority.
Payment channels, you can do payment channels without fixing malleability. Yeah.
There's much more important things that we need to be focusing our time and attention on, primarily scaling, supporting the payment processing ecosystem with additional APIs into the node so that they can query things and improve zero-conf experience and measure zero-conf risk and that sort of thing. Yeah, it just doesn't seem to be a priority to me. Our core priorities are, well, one, keeping Bitcoin SV code secure in terms of quality of code, etc., and making sure no vulnerabilities creep in. our other two core priorities are scaling and improving the instant transaction experience for users. I think when we have those two things in place, we can stand in front of the world and say, hello, here's this blockchain that has taken a radically different approach to all the other several thousand blockchains in the world when it comes to scaling. We're not afraid of big machines. We're not afraid of data centers. And by the way, here's a block that's this size, and it processed a whole bunch of transactions that happened 10 minutes ago, and the people have been out of the shop drinking their coffee for 10 minutes. Then I think the world will take notice.
Just out of curiosity, how far do you think we are from that, where this adoption is going to grow at a significantly high rate, and we're going to need to scale?
I think I talked at the very beginning of this session about the interaction between the different developer groups, and how I think once the protocol, the consensus protocol itself starts to settle down, and I think it's quite close to that. If we reach a place where that's happened, then a lot of the time and energy that gets wasted on sort of non-productive confrontational interactions will get focused on these things. The scaling stuff, for example, BB have already done some great work on that, and I hope they continue. So, depending on the outcome of what happens in November, if we get to a position where people are no longer focusing on all of these consensus changes that need to happen, in quotes, then I think the attention of developers will get laser focused on scaling and zero conf, and I think the pace of adoption will pick up. I can't give you an exact date, but I'm really excited to see where we're at in the middle of next year. I think I definitely, from the Bitcoin SV side, I know we're going to have made huge amounts of progress between now and June next year.
Can't wait.
Wonderful. We, I guess before we kind of wrap this up with one last question, I did want to address anyone who was like, oh, they didn't ask my question. I think a lot of people confuse you guys with miners. A lot of these questions are assuming you personally are going to 51% attack things and things like that. So we didn't answer your question. These two are not the miners. I think a lot of people do not understand that whatsoever. With that said, we were accused that this was going to be a softball interview, and then I had to, so now we kind of were forced to ask this question here. There's one user particularly obsessed with your chief scientist at nChain. And so
let me guess, contrarian.
Yes. I think his name might be Greg, but I'm not sure about that. And the question is that because your client claims to implement Satoshi's vision, do you personally think that Craig Wright is or was the main part of Satoshi? And you go for that.
I have a blanket policy of ignoring contrarian because I generally try to be a little more diplomatic, but I mean, he is clearly an idiot in search of a village. On the question of do I believe Craig Wright is Satoshi, it doesn't matter to me whether he is or not. Thought hard about this. If I was offered a cryptographic proof, I think I would probably say no, because I think that would just fundamentally change something, and it really just doesn't matter. Craig is an interesting character. I actually enjoy working with him. I find him prickly sometimes. We have our disagreements, and some of them get a bit loud, and then we have a hug afterwards, and it's all good. But in general, Craig's somebody that I enjoy working with, and that's all that really matters to me.
Yeah,
great.
I'd agree with that. I mean, when I came to join nChain, I had to have a think about it, and what it comes down to is it doesn't matter if he is or not, really. I enjoy working with him, and it's a great place to work.
Wonderful. Well, thank you guys very much for taking the time to do this. I think a lot of people will learn a lot. I know I did. So we Yeah, we greatly appreciate your time. So thank you guys.
Thank
All right,
you.
it's been a pleasure.
Yeah.